Hello students. In today's class we'll be talking about the third chapter of your NCERT, that is chemical classification and periodicity. So in today's class we'll first see what does chemical classification means. Well, as far the elements are concerned, as the knowledge of elements grew, it became difficult for human beings to remember their all chemical and physical properties. So what they thought, why not to classify them in such a way that elements having similar chemical properties will be grouped together. So that if you know the chemical and physical properties of that group, you know chemical and physical property of all the elements which belong to that group. A lot of evolution has occurred in this field. In your previous classes, you might have learned about Dobrunier's triads, Newland's law of octave, and also Mendeleev's periodic table. In that, you might have done the classification according to Mendeleev's periodic table. You might have studied about the Mendeleev's periodic law. Because according to Mendeleev's periodic law, all chemical and physical properties exhibited by an element are the periodic function of their atomic masses. Based on that, we studied about Mendeleev periodic table. This is a layout of Mendeleev's periodic table. You learned about merits and demerits of Mendeleev's periodic table. What were the merits and what are the demerits? Like there was no place for isotopes. Some dissimilar elements were grouped together. Some elements which were having common property were placed apart in that periodic table. Position of hydrogen was not certain. So there were some demerits of Mendeleev's periodic table. Well, after that came modern periodic law. It was given by Moseley. Moseley was carrying an experiment on X-rays, and he found that in case you apply the same potential difference but you change the metallic plates, you use different metals, the frequency of the X-ray was changing. Why these X-rays they were generating? Actually, when you were applying high potential difference, the electrons they were jumping from lower energy level to higher energy level. Then these electrons they were moving back from high energy level to lower energy level, and they were losing energy in the form of electromagnetic radiation, and that was lying in X-ray spectrum in that band. So he observed that if you apply the same potential difference but change the metallic plates, you use different metal plates, the frequency of those X-rays they were changing. From there, Moseley determined one thing, that this frequency, why it is changing, because we are using different metals. And what is happening, there is a transition of electrons is happening. The number of electrons is always equal to the number of protons. Now since the number of electron is different, that means the number of proton is also different in different elements. And that number is known as atomic number. So Moseley gave the modern periodic law. According to modern periodic law, all chemical and physical properties exhibited by an element are the periodic function of their atomic number. The studies of your 11th standard starts from here, from modern periodic law. So according to modern periodic law, all chemical and physical properties exhibited by an element are the periodic function of their atomic number. Since different elements, they have different atomic numbers, so they exhibit different chemical and physical properties. Based on that, we got modern periodic table. So this is a layout of a modern periodic table. You can see it over here. This is how modern periodic table it appears. Well, as far modern periodic table is concerned, it is totally based on electronic configuration. I give you one example. We'll study about modern periodic table. Suppose I'm carrying out electronic configuration of an element, say iron, whose atomic number is 26. And I am doing this electronic configuration according to N plus L rule, that is Aufbau's principle. So what I'll write 1s2, then 2s2, 2p6, then 3s2, 3p6, then 4s2, 4s2, 3d6. See how many electrons? 10, then 20, then 6. My dear students, in this electronic configuration, you can see one thing, that when the principal quantum number was 1, in the first shell, you have only one subshell, that is S. And S can accommodate a maximum of 2 electrons. That's why when I talk about modern periodic table, in the first period, you can see this is the first period. In the first period, you have 2 elements, that is hydrogen and helium. Every single element over here represents 1 electron. So in the first shell, you can put maximum of 2 electrons. That's why first period has got 2 elements, hydrogen and helium. First shell has got only one subshell S. That can accommodate a maximum of 2 electrons. So in the first period, you will have only 2 electrons, 2 elements. Now, if I talk about the second shell, you can see here. In this second shell, you have 8 electrons, 6 in the P and 2 in the S. So if we have a look at the periodic table, the second period will have 8 elements, 1, 2, 3, 4, 5, 6, 7 and 8. Out of these 8 elements, 2 elements they belong to S subshell, so they are in the S block, and 6 electrons they belong to P subshell, so they are in the P block. Then again we'll move on to the electronic configuration. Third shell, if I talk about the third shell, you have 3s2 and 3p6. That means the third period will again have 8 elements because you have 8 electrons. 2 plus 6. So 2 of the elements they are in the S subshell and 6 of the elements they are in the P subshell. So total is 8. Now if I talk about the next shell, 4s2, 3d6. Well, what you generally write, that is 4s2, 3d10, 4p6. This is how you can write. This, in case you want to fill this fourth shell completely, then this is the electronic configuration you'll do. So let us have a look at the periodic table. If I talk about the fourth period has got 4s, then it has got 3d, then it has got 4p. So if I talk about iron, the electronic configuration of iron is 4s2, 3d6. 4s2, whatever the principal quantum number of the last S is, the element will be located in that particular period. So this element, that is iron, will be present in the fourth period. And which group? That is the total number of electrons. 6 plus 2, 8. So it will be in the 8th group. So this is the fourth period you have got. In this fourth period, you will see this element, that is iron. And in which group? 8th group. So this is how we locate element, and this is how the modern periodic table is made. This modern periodic table is basically the electronic configuration. The electronic configuration of any of the element. So based on electronic configuration, this modern periodic table is formed. Now suppose I have got a nucleus over here. This is the first shell. First shell can have maximum of 2 electrons. I have second shell. Second shell can have maximum of 8 electrons. If I talk about the third shell again can have maximum of 8 electrons. Fourth shell can have 18. (17) and 18. So if you have a look at this periodic table, the fourth period has got 18 elements. Every single element represents 1 electron. So we'll see the characteristics of modern periodic table. What are the characteristics of modern periodic table? You can write down. Modern periodic table is divided into 4 blocks. that is S block, P block, D block and F block. So modern periodic table is divided into 4 blocks. The modern periodic table is divided into 18 groups. You'll see these horizontal columns which are groups and 7 vertical rows, they are known as the periods. So you have 18 columns, they are groups and 7 periods. So modern periodic table is divided into 18 groups and 7 periods. The first part is known as the S block, then you have the D block, then you have the P block, and below this main periodic table you have the F block. S block basically means the S subshell. S subshell can have maximum of 2 electrons. That's why this S block is divided into 2 groups, 2 vertical groups. If I talk about the P subshell can accommodate a maximum of 6 electrons. That's why P subshell is divided into 6 vertical columns. They are groups. So it will have 6 groups. If I talk about the D block can accommodate, the D subshell can accommodate a maximum of 10 electrons. That's why D block has 10 elements. So in the first row, if you see, the element they start from scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. And below that also you have some elements. So that means the D subshell is divided into 10 parts because it can accommodate 10 electrons. If we come below this main part of the periodic table, you'll see F block. F block is again divided into 14 parts because F subshell can accommodate a maximum of 14 elements. And as far those elements are concerned, you can see that the first series in F block, you have 2 series. The first series is known as the lanthanoids because they come after lanthanum. And the second series is known as actinoids because they come after actinum. The lanthanoids, they start from cerium and they end at lutetium. And if we talk about the actinoids, they start from thorium and they end at lawrencium. Most of the elements which belong to F block are heavy metals and they are generally radioactive. So these are the characteristics of modern periodic table. After modern periodic table, after discussing its characteristic, we can talk about its merits and demerits. As far merits are concerned, it is the most successful classification of elements based on their electronic configuration. So if you know the atomic number of an element, you can easily locate that element in the periodic table. So as far modern periodic table is concerned, it is based on electronic configuration of elements. So it is the most successful attempt of classifying elements based on their electronic configuration. The second merit is that it can accommodate isotopes. It was a demerit of Mendeleev's periodic table, though that periodic table was based on atomic mass, but it could not accommodate isotopes. Modern periodic table can accommodate isotope because isotopes, they have the same atomic number. So suppose I am talking about a hydrogen which has got 3 isotopes, that is protium, deuterium and tritanium. Although their atomic number is same, their atomic mass is different, but they can be accommodated at one position where hydrogen is written. So all isotopes can be accommodated there. Likewise, if I talk about carbon has got 2 isotopes, carbon 12 and carbon 14. Both of them, they can be accommodated at the same place in 14th group, topmost element, that's carbon. So there you can accommodate them. So these are certain, it is very easy to learn. This is the best merit of modern periodic table. It is easy to learn and to rewrite. You can easily learn it. If you know electronic configuration, you can easily locate an element in the periodic table. So it is easy to learn and to rewrite. As far demerits are concerned, there are mainly 2 demerits of modern periodic table. The first one is that it does not have a proper position of hydrogen. Hydrogen in some of its chemical and physical properties resembles first group elements. And in most of its chemical and physical properties, it resembles the 17th group elements. So there was a question where to put it. So as far the position of hydrogen is concerned, it is not very certain in the modern periodic table where to put it. The second demerit is the position of F block elements. The F block is placed outside the main body of the periodic table without any explanation. So the position of F block again is a demerit. So this is all about the characteristics of modern periodic table, the merits and demerits of the modern periodic table. In the second video, in the next video जो अभी आएगा आपके पास, जो दूसरा वीडियो मैं बताने वाला हूँ, उसके अंदर मैं आप लोगों को करवाऊंगा periodic properties को. So periodic properties what we are going to in the next video. Please do watch that. It was something about chemical classification of elements. So that's all for this video. Thank you very much.